This is the most important enzyme in the conversation. So the core concept here is that Psilocybe cubensis produces psilocybin and psilocin through a defined four-enzyme biochemical pathway. Each enzyme performs one specific chemical transformation in sequence. And those enzymes do not exclusively recognize their native substrate, but they also have a tolerance for related molecules. So doping really equals introducing the exogenous tryptamine into the growing substrate. And if the molecule is structurally compatible with one or more of the enzymes, it will produce a compound that it could never make on its own. And so the output obviously depends on which enzymes the foreign molecule can use, which enzymes it bypasses. And an example of this is if you feed it DMT, it's already dimethylated, so it will skip the dimethyl or the methylation enzyme and the PSIM enzyme and the PSID enzyme because it's already methylated and it's already decarboxylated. And so then this moves into how efficiently the enzymes work on the modified ring structure. And so we'll talk a little about the four enzyme cascade of events as it's inside the medium or the substrate of the mushroom. So, and then I'm going to talk a little here about what the enzymes actually are. So PSID enzyme is a decarboxylase enzyme. And what that does is it decarboxylates tryptophan into tryptamine. And obviously, when you feed it a preformed tryptamine, like dimethyltryptamine or 5-MeO tryptamine, it bypasses this enzyme. This enzyme isn't used, so it just kind of stays where it is and does its thing. And then we have the PSIH enzyme, which is the P450 monooxygenase enzyme, and that adds a hydroxyl group at the 4 position of the indole ring. And it's a rate limiting step, requires NADPH as an energy source to actually do the process. And it's a very critical determinant of doping success because that's what we're looking for. We're putting these tryptamines in so we can have them 4-hydroxylated. And this is the most important enzyme in the conversation.